I started, but I didn't finish, is what I'm saying.
Isn't this a wonderful beginning to lesson 7? Look at all the homework Jane's done. Would you like to explain what everything is?
Not really, because I'm so tired from doing it.
We've worn her out. So what have we got here?
Well, I've done
Seven.
No, I didn't do 7. I did, that's 8, 9. I had to do 9 because I really liked 9s from the class. So I had to redo that again because I really liked it. Then I just did 2, 4 and 8. And then on that one I'm thinking I couldn't decide what I wanted to do, so I didn't do it. So I thought, well, I'll just do that. The hardest part was trying to handle a compass. I haven't used a compass for years and I found it really, really difficult. And none of my children's pencils, because they're all Steiner pencils, wouldn't fit in the compass. So I'm there with the compass going, now what do I do? So I had to go and buy another compass that already had a lead in it.
We brought one. I was using plates.
I don't have enough plates.
Saucepan lids, plates.
Look, that's beautiful.
I thought about that too.
Look what Jane's done here.
But I only did the 2s.
That's wonderful. That's wonderful. Look how neat that is. That is, isn't that beautiful? Very neat. Very, very neat. Well, wonderful. Wonderful, wonderful.
White little stickers all over the place for all the mistakes I made.
Anybody got anything to share about their homework? This is so exciting, seeing all this wonderful creative work. It's great. Look at this. It's great.
I did use white out.
I had a little rubbing out myself. So, what I've done on the board, I only went to 50 because if I'd made the numbers any smaller, I think they wouldn't have been visible. Can you see where I've gone to 50 and the ones on the top?
Yeah.
Odd 1, even 2, odd 3, so that's the ones. Then underneath the ones, in the 2s, even 2, even 4, even 6. This is what we covered last week. Then we pulled out 2 2s make a 4, another 2 2s make a 4, another 2 2s make a 4. Can you see that, everybody?
Mm-hmm.
Grant?
Yep.
Yes. And then I did the 8s, where we've got 2 4s makes an 8, another 2 4s makes another 8, another 2 4s makes another 8. So we are not working from memory or counting, we are connecting the 2s and the 4s and the 8s. So I think, Jane, you've done 16?
Yeah, I think
Jane's done 16. How would she have done 16? What would she have related 16 to?
Well, I cheated because I know 16 and 16 is 32, so I cheated on the
Yeah, but
first
that's not what necessarily what I want you to do. That's very good.
I'm going to cheat.
But what am I connecting the 16 to? The 8s. So what am I saying?
2
2 8s.
2 8s.
1 8, 2 8s, 1 16.
Yep.
Another 8 and another 8. So that'll be the next
32.
16 will be the 32. You see what I mean about pulling out the 8s? And then we go another 8 and another 8, and that'll be another 16. You all with me?
Yep.
Yeah.
So we're not counting. We're pulling the numbers out from previous numbers. So what we're saying is that we're not learning times tables, we are relating numbers to other members of their family. So we've got the family 2 4 8 has now been extended to the family 2 4 8 16. Who would be the next member of that family if we were to keep? Yes, Jane?
32.
It would be 32. 32 would be the next member of that family. Then we could pull out the 32s, couldn't we, from the 16s. 2 16s makes 1 32. You with us?
I have to draw all the lines.
Yes. Look, the thing is, there's no limit. You can keep going. If you're excited about it, you can keep going. That's what's so nice about it. Now, what I'm interested in is whether we are connecting what we did with the pebbles with what we did with the circular wheels, with what we're doing with this. I'll give you a moment to think about that. I'll give you a little moment to think about that. For example, dividing 16 by 8. Two, 4, 6, 8, 10. 2, 4, 6. There's 16. If we divide that by 8 with the pebbles, what are we looking for? We're looking for the 8s, aren't we? Yeah? Remember the story? I've got 16 ice creams and 8 children to share with. How many are they going to get each? They're going to get 2 each, right? There's 1 8 and there's another 8. Stop me if you don't understand, Grant. Yeah, you happy with that? Everybody happy with that? So in our circle, can I have your 8 wheel, please? Jane, the master of the homework. So here we've got an 8 wheel. So we're looking for 16. I'm going to make my glasses. I've gotten away without having to wear glasses for 7 lessons. Okay. So we're looking for...
I hope I got that right.
We're looking for 16 on the 8 wheel, aren't we?
Yeah.
And we're seeing it's 2 8s with nothing left from our wheel. Everybody with me?
Mm-hmm.
Good. Lovely. And so here we're looking at 16 and we're seeing that it's 2 8s. Right? So we're connecting the pebbles, the circular charts, and this called the multiply chart together. Now I think this is step 1 in understanding multiply and divide, and I think the wheels are step 2 where we're introducing the remainders and we're seeing the connection between every number and that number. For example, if I can borrow your 8s again, 8s here we'll have 8, 16, 24, they're the whole 3s, the whole 8s. 1 lot of 8, 2 lots of 8, 3 lots of 8, 4 lots of 8. But here we can relate any number to an 8, can't we? We could relate, let's say 46. 1, 2, 3, 4, 5 lots of 8 and 6 remainder. Now here, if we had 46 in the 8s, we could also see that it's nearly 6 lots of 8. It's 2 short of 6 lots of 8. So it's 5 lots of 8 and 6 remainder. We're seeing the connections?
Mm-hmm.
So I like to use all 3 mediums to work with the topics of multiply and divide. There'll be some people who want to stay here for a long time. There'll be some people who love the circles, the wheels. Grant liked the wheels better than the pebbles. And there'll be some people who think this is the bee's knees and want to work with that. I find the children, once they graduate to this, get very excited because they can do all their homework using this like very quickly. Adds, subtracts, multiplies and divides. Alright, so do we all see how to divide by and multiply by 2, 4 and 8 using this chart? If I say what's 3 times 8 or 8 times 3, where do we go? Which row do we go to? Yes?
Yeah.
Yes, you can speak up, Jane. We go to the 8s. This is 1 lot of 8, 2 lots of 8. Is that 4 lots of 8?
Sorry, 3.
Yes, can you see that that's another 2 4s, Grant?
Mm-hmm.
Yes, it's not a double.
Yeah.
Yeah. 1 lot of 8, 2 lots of 8. Let's count. 1 lot of 8,
2 lots of 8, 3 lots of 8, 4 lots of 8, 5 lots of 8, 6 lots of 8.
So if I say 48 divided by 8, it's 6. Because there are 8 6s. There are 6 8s inside that 48. So we can see now we can multiply and divide with our 2s, 4s and 8s. We all got that? So now, we could look at our 10s and our 5s. I think that's where we went to next. When we were looking at multiply and divide, we can go to our 10s and our 5s. So our 10s, what colour do I need for our 10s?
Blue.
Blue, why?
Even.
They're all going to be even, aren't they? So, call me out the 10s. We've got even 10, and the next 10,
Even 20.
even 20.
Even 30.
Good, we've got this.
40.
30.
I could have like
Oh, oops, 20. Look at me, I say 20 and I write 30. Okay. 20. And then the next one,
30.
even 30. And the next one,
Even 40.
even 40. Lovely. And now, what's the relationship of 5 and 10? What's the relationship of 5 to 10?
2 5s make a 10.
2 5s make a 10. 5 is half of 10. 1 10 makes 2 5s. You see how many different ways we have of describing this relationship? What colours, tell me about my colours. I'll need
Red.
all red. Will they be all red? Odd 5.
Red
And blue.
I need red and blue, won't I? If I'm multiplying by an odd number, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I doing? Changing sides. If I'm adding an odd number, I change sides, don't I? If I'm in even and I'm adding an odd number, I'll end up in odd. If I'm in odd and I'm adding an odd number, I'll end up in even. So with the children, if that's not clear, we go back to the beginning, make sure we understand that when we're multiplying with an odd number, we are changing from odd to even, even to odd. Okay, so who can call for me please? The 5s. Odd 5, even 10. Am I on the right line here? Next one,
odd 15.
odd 15. Whoops, that's very difficult from this perspective.
Even
20.
odd
25.
even 30.
Even 30,
Odd 35.
odd 35,
Even 40.
even 40,
Odd 45.
odd 45, even 50. Why have I got 50 there in red?
Because you haven't got the 49.
You haven't got 49.
I missed 49. You see how easy it is to make a mistake? And I didn't even notice it.
How'd you
before.
reach up there?
I was on a chair all morning. I was on a chair all morning going crazy and I managed to make, that's my second mistake. Right,
That's not bad.
2 mistakes. No, and it's a great practice in who cares about a mistake. We just rub it out and start again. Or if we feel we've messed up our chart, do another chart.
Oh,
You
no,
know.
all the notes on again.
What's going on, Ellie?
It's all right doing a lot of work. Good ethic to build. Okay, so we're seeing 2 5s makes a 10. Who can tell me, how do I predict if I'm going to get an odd number or an even number if I'm multiplying by 5? Do we know what I mean?
No.
So if I say 5 times an even number, 5 times an even number, I'm going to get
Even.
an even number. 5 times an odd number.
Odd.
So if I say 5 times 13, 13 is a odd number, what's it going to end in?
5.
It's going to end in a 5. 5 times 27 will end in a
5.
5. 5 times 48 will end in a 0. Right? This makes us clever already, doesn't it? Well, it's good to connect all these things, so then when we're working with numbers, we see, if we have made a mistake, we see it very, very quickly. Are you right with that, Grant? Or, yes?
Yeah.
Good, good. Lovely. Does that apply to all the other odd numbers? If I say 3 times 17, is that going to be an odd or an even? What's 3? 3 is odd. 3 times 17, an odd number of odds. Not sure? Okay, we'll get there when we get there. What about 5 times 17? That'd be an odd. So where's the hesitation? There's only 2 sorts of numbers. There's only odds and evens. All the odds behave the same, all the evens behave the same. You don't trust yet. So if 5 times 17 is an odd, well, what's 3 times 17?
Odd.
Odd, because you've got an odd number of odds.
I think so, I'm thinking you add. If you add an odd and an odd, you get
If
it.
you add an odd and an odd, you get an even. But if you have an odd number of odds, let's look at an odd number of odds. What have I got here?
3.
3.
3.
One lot of 3, an odd number of odd. Do you see what I'm saying? You got that? Odd number of odd. What have I got now?
An
Even
even number.
An even number of odds. And that is what sort of a number?
Even.
Even. Odd number of odds, and it is odd. That's law. Doesn't matter what the number is. 47 times 93 will be a odd. 47 times 92 will be a even. Odd number of evens, or an even number of odds. I'll drive you all nuts. You can play with it.
I mean, I have to remember one even must have got.
We don't remember anything. We just play with pebbles and we work it all out. This was a revelation to me when I discovered all this. And I went dancing around the house shrieking Eureka every time I got a new... I don't know what the neighbours thought. Okay, so what should we do next? We've done 2, 4, 8 and 5 and 10. Where should we go from here? Maybe everybody's dying to get to the 3s. You want to go to the 3s? We'll go to the 3s.
Sorry.
We know our first lot of 3 is
Odd.
odd 3. Our second lot of 3, even 6. Where are we? Even. You just wanted to see me.
Do you want
Down, tippy
Grant,
top.
would you like to come and do the 3? Now, you have to do everything very neatly so they don't clash into the 4s. Okay, the first one is odd 3,
Just repeat.
then
6.
even 6,
And then odd 9.
odd 9,
And then even 12. Odd 15. Even 18. Odd 21. Even 24. Am I doing alright?
you're doing beautifully, Grant. I'm not disturbing you.
Odd 27. Whoa! I always do that. They make a lousy teacher. Very chalk. Where are we? Odd 27, even 30. Can I just do all the reads?
No, you cannot. Why won't I let Grant do that?
Oh,
Because he's counting the 3s as he's going along with it.
yeah.
Because it's not the truth.
Yeah. And that's when you have to use a lot of weight out.
And the patterning is the important thing, to feel the patterning.
Almost did 54 then. Just like
Well done, Grant. Well done. Now, I wanted to ask you, Grant, whether working working with the odds and evens like that helped you to know what the next number was going to be.
Yes, definitely.
There we go. There we go. Now, can you see why I won't let you do all the odds and do all the evens? Because you destroy the patterning. Now, for Grant, who prior to this class wouldn't have known the threes, would I be right, Grant?
I'd have to count.
He'd have to count, right? Because he has this pattern, he can predict the threes. He can predict the threes, which makes life easy. Makes life very easy. Now with our threes, we only have to know the first three. Odd 3, even 6, odd 9. That's all we have to know to predict the rest. If one lot of 3, let's look at them here, right? I know what 2 lots of 3 are, so how would I work out what 4 lots of 3? Double 2 lots of 3. I know what 3 lots of 3 are, how would I find 6 lots of 3? Double. I know what 6 lots of 3, how would I find 12 lots of 3? Double. I know 3 lots of 3, so do I know 9 lots of 3? Double. Right? So that takes care of all the odd numbers of 3s. You with me?
Mm-hmm.
So if we work with that, 2 lots, 4 lots, 6 lots, 8 lots, we know 10 lots, 12 lots from 6 lots. So we've got all the even numbers of 3s. Right? Stop me if it doesn't make sense. So the odd numbers of 3s, we know fit in the middle, don't we? So if I say 5 lots of 3, it's an odd number between 4 lots of 3 and 6 lots of 3. Right? 4 lots of 3 is twice 2 lots of 3. 2 lots of 3 is... So 4 lots of 3 is... Let's say our evens and odds. What was up to? 4 lots of 3 is even 12. Alright, we'll go back. 2 lots of 3 is even 6. 4 lots of 3 even 12. So 5 lots of 3 must be a odd 15. If you play with it long enough, it'll just pop. Okay, I want 7 lots of 3. So I'm going to do 6 lots of 3. So I'm going to go to do 3 lots of 3. 3 lots of 3 is, even or odd? Odd 9. So 6 lots of 3. 3 lots of 3 is odd 9.
No, sorry, I just count. That's all.
No, don't count. Right. Don't count. Don't count. That'll lead you astray. 3 lots of 3 is odd 9. So 6 lots must be an odd and an odd. Must be even 18. You seen that, Grant? So what am I up to? So 7 lots of 3 must be a odd. So 21, 18. And the next odd for us, if we're adding a 3, are we seeing it or not? No? We've got even 18 for 6 lots of 3. If I'm going to have another lot of 3, odd 21. Just takes a little bit of playing. So I know what 8 lots of 3 is. I go back to 4 lots of 3, back to 2 lots of 3. 2 lots of 3 is,
6.
say your odds and evens. Even 6. So 4 lots of 3, even 12. So 8 lots of 3, even 24. So 9 lots of 3 must be a odd 27. Bingo. It just jumps out of your mouth. You've got it. So it doesn't take much to play with the 3s before they're there. I don't know, but when I was at school, the 3s eluded me. being able to just go 7 3s to 21. You know, I couldn't memorise them. I didn't have a pattern, so it was meaningless. But now 7 3s is an odd, 6 3s is an even, 8 3s is an even. It's the odd between 6 3s and 8 3s. 6 3s I've got from 3 3s. 8 3s I've got from 4 3s, 8 3s. So we only have to be familiar. Am I talking too quickly?
You'd be a good auctioneer. It's just still going. I wanted a bid.
3 3s. Can you see that's all we need to know? 1 lot of 3s odd 3, 2 lots of 3s even 6, 3 lots of 3s odd 9. And we build from there and we play from there. We do not memorise and we do not encourage the children to memorise. We build from there and the children very, very quickly get the 3s. Right? So we could go to the 6s now. Now I can see you're all thinking, oh, 2 3s make a 6. We can do it that way, or what's the way we looked at 6s before?
The 2s.
Could do it with the 2s, a bit slow. What did we do with the 6s? How did we work out the 6s? Six lots of 14. How did we how did we pattern for 6 times 14? 5 lots, didn't we? So we could do 5 lots of 14 is 70, so 6 lots is 84. That's the way we looked at it when we started the first way of looking at it. Now we can look at it as 2 3s, couldn't we? We could look at it as 2 3s. You see how it's limitless, how we can look at multiply and divide? I could work with you on multiply and divide for 3 years and not retrace my steps on different ways of looking at it. And this is what we want for the children, that they're not just learning it off by heart, but seeing patterning in different ways. And that way we're sure to find a way that suits every child, so that every child understands maths. So, who would like to do the 6s? What colour are we going to use for the 6s?
Blue.
Blue, why? Because?
They're evens.
Because they're all even. So an even plus an even is an even plus an even is an even, isn't it? So who'd like to pull out the 6s?
I won't be able to reach.
You can't reach.
That's
That's a great excuse. Who'd like to pull out the 6s? Is it only Grant who's tall enough?
You can't reach the 6, really?
Really, I can't reach the 6.
Oh God, you'd be surprised yourself.
I'll try. If you can reach, I can. Sure, that's
That's right. I don't know whether I
I'm
can
sure
reach
you
the
can. I
6s.
would not be able to reach the 6.
So where are you going from, the 3s, or what are you doing? Tell us how you're doing it. How are you finding out the next lot of 6?
I would probably go 2 3s.
2 3s, good. So that'll take you to
12.
even 12.
Even 12.
Even 12.
Am I high
on the
enough?
yes,
Yeah.
she's on the toes. And then,
Even 12.
You come a bit lower.
Even 18.
good.
Lower, did you say? Even 24.
Beautiful.
Even 30. No. Is that right?
Now she didn't trust. All you have to do is count.
There's too many numbers above me.
Yeah. This is why it's so important to be neat,
Even 36.
because this chart isn't as neat as the ones that you've done.
Even 42.
Mm-hmm.
Even 48.
Perfect. So Jacqueline's pulled out the 6s by relating them, well done, to the 3s. 2 3s makes a 6. I personally like this way of doing my 6s, rather than relating them to the 3s, but that's perfect. Yeah? So if I was to say 4 6s, I say 4 5s is 20, plus a 4 is 24.
So how would you do 5? So you would go 5 and then add 1?
In my head, I do it in my
Okay,
head.
on the chart. So you're not saying.
What did I say? 5 6s. What was the sum I said? 4 6s. 4 6s, I do 4 5s is 20, plus another 4 is 24. But here we do 4 6s, 1 6, 2 6s, 3 6s, 4 6s. 4 6s are 24. 24 divided by 6, 1, 2, 3, 4. See, we can multiply and divide. You see, we all clear with that? We all clear with that? We can see remainders, but they're not that clear. You know, we'd have to count the remainders. But the remainders are more clear in our beautiful number wheels. All right, so we've got 1, 2, 3, 4, 5, 6, and 10. We could do 11. We could do 11. What's 11 in the big scheme of things? It's a 10 and a 1, isn't it? Who would like to do odd 11? What colours will we need for odd 11? Blue and a red, won't we? Because we'll be going odd, even, odd, even. So do I have a volunteer for 11? Odd 11?
I think I heard little volunteer.
No.
Odd 11. Well done. I need to get another.
So 22 in the first
I
one.
want to hear odds and evens.
Oh, even 22.
Odd 23.
Even 44.
Perfect. So we haven't got very many in the 11s, have we? Because we're moving by big numbers now, aren't we? All right, we could do the 12s, couldn't we? Where can we go to do the 12s? From the... Who can we relate even 12 to?
6.
Even 6. So we could pull out the 12s. Would you like to come and pull out the 12s?
Okay. Thank you.
What colour will we need?
Blue.
Blue.
Oh,
So here are the 6s. 1 6.
yeah.
2 6s is 1 12.
Yeah.
Another 6 and another 6.
Even 24.
This line.
Yeah.
Another 6 and another 6. How many 6s?
Oh.
How many
No, just
6s?
the two,
Just
yeah,
the
sorry,
2, that's
36.
right.
36.
And that's it, isn't
Yeah.
it? Oh no, we've got more space. We've got 2 more 6s?
Yeah.
48.
48.
Perfect. Can you see we've got the 12s there? Lovely. Now who'd like to do the 9s? Odd 9.
Oh, the doors are locked.
No, it's in the store. Who would like to do odd 9? One lot of 9. One lot of 9 is... Say your odds and evens for me, Graham.
Sorry, odd 9.
2 lots of 9. Yes, because the way we did it before, we related it to 10, didn't we? 2 lots of 10 minus 2. So 3 lots of 9 will be 3 lots of 10 minus 3. 4 lots of 9, 4 lots of 10 minus 4. Right, so who would like to do the 9s? And what colours do I need?
Blue and red.
Blue and red, because 9 is a... No, the dark one, don't it? That's the light
That's the
one.
dark one, isn't it?
This colour one.
It's the light one.
Thank you. Who would like to do the 9s? Jane. Shaking your head so conscientious.
I was looking forward to doing the 16s.
All right, well,
Because there's only 2 of those.
Jane, come and do the 16s here. We don't want to deprive you. What colour do you need?
Oh,
What sort of-
even, red, blue.
Okay.
So you got 16.
Yes. So what are we going to relate it to?
8s.
8s.
Oh, you can't. Can I look at my thing?
Here's your 8s. Here's your 8s.
It's really hard to
1 8, 2 8s is 116. 1 8, 2 8s, 32. That's it. That's it. And that's about it.
That's why I wouldn't do that
Good
one.
job.
Is there another one?
Is there another one?
48. There is 2, yeah.
Have you got 2 more 8s?
48.
Go up to your 8s and see if you've got another 2 8s.
Yep.
There we go.
Okay.
So here's a question, Jane.
Oh.
Let me sit down. So 3 16s, listening everybody and just watching the board. 3 lots of 16 is how many lots of 8? 3, look at the board, don't think so much. 3 lots of 16 would be how many lots of 8?
6.
Perfect. 6 lots of 8. 6 lots of 8 would be how many lots of 4? 6 lots of 8. 6 lots of 8. 1 lot of 8, 2 lots of 8, 3 lots of 8, 4 lots of 8, 5 lots of 8. 6 lots of 8 would be how many lots of 4?
12.
12. You're not calculating numbers, are you,
I
Jane?
don't know what I'm doing.
Not sure what I mean?
Yeah, I've got a bit lost when...
Okay. 2 lots of 8, Jane. 2 lots of 8
Yep.
is how many lots of 4?
Um,
Just looking at lots of.
this is where I get stuck on your chart.
2, use your own view.
You're looking up there, there's too many blues.
Too many blues.
But there is a line too.
2 lots of 8.
Yeah.
2 lots of 8 is how many lots of 4?
16.
That's the number that it equals. But how many lots of... It's 4 lots of 4.
Yeah.
You with me now?
I am now.
2 lots of 8 is the same as 4 lots of 4. 2 lots of 8 is how many lots of 2? Without counting. Without counting. 4 lots of 4 would be how many lots of 2? 4 lots of 4 lots of 4 would be how many lots of 2?
8.
Yeah, you don't have to count.
No, it's just look at the 8.
8.
Yeah.
Lovely?
Yes.
Yes, we need to let go of counting and see the patterns. If you don't see it there, we make pebbles. So with the children, folks, please always have your big basket of pebbles handy. If we don't see it that way, we see it that way. If we don't see it that way, we see it, put the circles on top of the circles, or there's always another way to see it. So we're now connecting the different multiply tables, as we call them. So if I say 4 lots of 12, 4 lots of 12 is how many lots of 6? 4 lots of 12 is 8 lots of 6. 8 lots of 6 is how many lots of 3? 8 lots of 6 is 16 lots of 3. You with us, Grant?
Yep.
Yes, lovely. So here's another way of doing our multiplies. If I have to do 3 times 16, I can change that and I can say it's 6 times 8. If I am asked 3 lots of 16, 1, 2, 3 lots of 16, I can change it to groups of 8. Here's my 8 row. How many 8s in 3 lots of 16? 6 lots of 8. If I still don't know what that is, 6 lots of 8, I can change that to lots of 4. 6 lots of 8 is 12 lots of 4. I still don't know what that is, so I'm going to change it to lots of 2. 12 lots of 4 is 12 lots of 4 is 24 lots of 2. That's a doubling. 24 times 2 is 48. So that's another way of looking at 3 lots of 16. 24 lots of 2. You see how we can change things? If we don't like it, we change it. Isn't that comforting? Because many children wouldn't know where to go with 3 lots of 16, but they know what to do with their mirror game, with their doubling, with their lots of 2, so change it. You don't like it? Change it. And we can change numbers as long as we see their relationship to other numbers. We can always find it. You like that, Jane?
I like that.
Yes.
We can change it. You said it before, I've written it down before.
Yes, if you don't like it, change it. Before, that was if we had an odd number of 10s and we were dividing by 2 and we didn't like it, we change it to an even number of 10s. Then we can go ahead. So it's always, if we think we're stuck, we change it. A lot of the frustration for children is they look at something, I can't do it, pencil goes down, spack attack, because I don't know how to do it, right? But if they know, if they look at it, that they can change it to something that they can work with, then they're prepared to work with the number. Both your children have been in that space, haven't they? Where they get upset and angry, I don't know what to do with this. Now they know to look at it and change it. What can I change it to? We know we can change it to something nice that we can work with. So that takes us out of the quagmire. So since nobody's going to help me with 9s, I'll have to do them myself. So I need a red and a blue, don't I? Do I have to do it all myself? You're going to help me at all? What colours do I need? Red and blue, because we're doing odd 9. So the next 9 will be odd 9. The next lot of 9 will be odd or even? Even 18. Here it comes. And the next 9?
Odd 27.
Odd 27. 3 lots of 9, 3 lots of 10 minus 3. Odd 27. Then odd or even? Even 36. We can take 2 9s, Grant, and double it. Couldn't we? For 4 9s. We can either say 4 10s minus 4, 36, or we can say double 2 9s, double a 10 and an 8, 3 10s and a 6. See how many ways we've got now? I'm on the wrong line. Here.
Yep.
Next one.
45.
Odd 40. Am I in the right spot?
Yeah.
Up a bit.
Close enough.
Close enough? Very hard to tell. So what have we got now? 11, we've got 12. We've got to do 7. Now 7, we haven't really focused much on 7. That's why it's a really good idea to do your number wheel for 7, for odd 7. Who's done one?
Yep.
Lovely. Lovely. Let's show. I've got chalk on my hand, so do you want to hold up your... Now, did doing the number wheel help you with your odd 7s?
I'm not sure. I just enjoyed the pattern.
You
The
enjoyed
colour.
the pattern? Yeah. What about you, Jacqueline? Did doing the wheel help you get a rhythm with odd 7?
I think so. I need to spend more time looking at them. I think there was a lot of the wheels to do this week, and so I actually concentrated on just.
So you could do next week, do
looking
an
at them.
odd 7 wheel, everybody. Do an odd 7 wheel because 7 is the one that we're probably the least familiar with. So do another 7 wheel and just really let yourself, don't learn anything, but just let yourself have quiet time when you're doing it. And I don't want you memorising, I don't want you going 7 1 2, you know, I don't want you doing that. I just want you to get into the rhythm of it. And do it when the kids are asleep or something, so you've got a bit of quiet head time. So what I do with the 7s is what I call I turn them around. So if I don't, 7 lots of something, I turn it to something lots of, no, the other way around. 3 lots of 7, I turn to 7 lots of 3. 4 lots of 7, 7 lots of 4, I guess I get so muddled up. So if I've got 7 times 4, I do 2 times 7, 4 times 7. If I've got 7 times 8, I do 2 7s, 4 7s, 8 7s. 8 times 7, 7 times 8, I use the 8. 9 times 7, I use the 9 times table, or 7 times 9.
So you
This
just
is
change
where I go
what
totally
you're
dyslexic.
comfortable with.
I change it around.
Yeah.
Anything I don't like, I turn it around. So which is the only one we've really got to know? Which one can't we turn around? 7 7s. That is the only one, as far as I've discovered, that we actually have to know. And 7 7s are 49. And that's the only one we've got to remember, because the rest we can turn around. So I want you to practice. Yes, Grant?
That's why you've missed it out.
That's what I've missed it out, probably.
49.
I have no idea what my head does sometimes. All right, does anybody want to do the 7s? You'd like to do the 7s? What colours do we need for the 7s? Odd and even. Oh, that's another colour. A few colours. I've got 3 blues. And
That's not.
That,
Is that right? That's not right.
No.
No.
okay. So we've got odd 7, even 14. That's 2 7s.
Yeah.
We've got to 3. We want 4. Where are we going to go to get 4?
29.
We can go to 2 7s, couldn't we? What can we do with 2 7s?
Double it.
Double it,
28.
and we'll get 28. The warning light was that you wrote an odd number in blue.
Yes.
Can you see that?
Yep.
Okay, so now we've got 5 7s. We don't like doing it with the 7s. Let's do it with the 5s. Will it be an odd number or an even number?
Odd.
And what will it end in if it's 5 lots of something?
5.
It'll end in a 5.
35.
35, odd 35. Good. So the next one is 6 lots, so could we go to 3 lots?
42. 42.
Yes, so say your odds and evens, even 42. Beautiful. And the last one, which is 7 7s I can't help you with, but you could say we just add odd 7 to our even 42, don't we, if we get stuck? Thank you. If we get stuck with 7 7s, we can go to 6 7s. We don't know 6 7s, we can go to 3 7s. Right? I want you to all be able to jump around the multiplies. And the same thing for dividing. If I've got 42 divided by 7, I don't like that. I'll half my 42 and I'll get 21. Do I know how many 7s in 21? 3. So how many 7s in 42? 6. So how many 7s in 84? 12. See how clever you are? If I'd said to you how many 7s in 84, you'd have all sat mute. But when I led you through 21, 42, 84, you're seeing the connection, double. Right? So if you build on that workings, this is the way I want you to work with your multiply charts, to see patterns, not just to fill in a whole heap of numbers, but to see the connections. That's why you have to take your time and have fun with it and make sure that you're nice and neat. So I'm sorry, you know, at school you have those great big long rulers to make things, but I haven't got one here, so I hope that's okay. So what are we noticing now? We've got our multipliers up. I'm not going to go any further, that's for you to go. We've got the basics up to 12. What are you noticing in regard to your odd and even numbers?
There's a lot more evens.
There's a lot more evens. Did you know that before we did this? No, that was something you weren't aware of, was it? Which ones are the odds?
You mean totally?
Which, how do you know where you're going to spring a red number? Only in the odds, and only
Every other time.
every other odd, so it's going to be the odd number of odds.
Yeah.
You got that now? I'll twist your brains. The odd numbers of odds are the odd ones. So if I say 43 times 97, odd. So when you're doing sums like that later on, if you come up with an even number, the light will go on. I was going to say the red light will go on. That can't be correct. 26 times 88, even if you come up with an odd number, you're incorrect. Now most mistakes in arithmetic are an error of 1 digit. If you know your odds and evens, you cannot make your 1 digit mistake. An odd plus an odd is an even plus an even is an even. You know what I mean? If you've got all these connections, you can never come up with a mistake of 1 digit. Yeah? My mother was an accountant, and I can remember at night she used to have one of those, remember the old adding machines and you pull the handle? Do you remember? Like a million years ago? And she'd invariably be 1 penny or $1 or something out. And I think this must have been where I got my stimulus to find a cure to this being one wrong. I just thought of that. All right, so now we have some popular numbers, don't we? Who would like to call out which number they like, a popular number?
24.
Grant, 24. Can everybody see how popular 24 is?
Yeah.
So 24 has a lot of friends. We call them factors. Remember we looked at this, we just began to look at this last week? 24 has a lot of factors, if somebody doesn't quite understand. A lot of numbers multiply together to make the 24. We seen that? So tell me the factors of 24 from the top. 1, 2,
3, 4, 6, 8, 12.
Bingo, they're the factors of 24. Now if I'd asked you that without this chart, I think you would not have known what I meant, and you wouldn't have known possibly how to get it. So now we can see all our factors. Find a number that's very unpopular.
5.
5. What are the factors of 5? 1 and 5. That's it. So 5 is called a prime number. That's the definition of a prime number. So when you've finished your chart all the way to 100, you will be able to pull out the primes. You'll be able to read along and pull out the primes.
7.
Not at the sevens.
11.
Not at the sevens. 7, 17, 27.
27 is
not
not, is
27,
it?
sorry,
No.
37. 47.
Right, that's interesting. So Jacqueline's already finding some patterning in the primes. Now, when I was at school, we had to know the primes up to 100. Ta-da! 50 years too late. It was always a bit of a mystery for me what the patterning was to find the primes. So this way you can pull out your primes up to 100. And primes are extremely fascinating numbers.
So, for the primes, is it like 3, 5, 7, 11, 13? All the ones just, they've got no other number on them?
They've got no friends.
Okay.
How easy is that?
Yeah.
Is that nice and easy? And later on we can look at more patterning connected with primes. But for the time being, we can, what I call, see the primes by their absence, by the absence of factors.
23 is all
It's the first time having no friends, isn't it?
First time
It sounds good, prime.
the primes, all right? So we can see the factors and we can see the primes, which we can't see in our number wheels. You see this is taking us a step further? Well, it's taking us into a different direction than the wheels or the pebbles. With the pebbles, with our multiply and divide using pebbles, our wonderful visual way of looking at it, that's all we saw, multiply and divide. Here we're seeing more things. All right, anybody seeing any other pattern that they would like to talk about? Yes?
That pattern of going down by 2 on the diagonal there.
We've got a diagonal pattern, haven't we? What's this one? This is the
Odds are even.
odd one. Yeah, we're counting by odd one.
Yeah.
And this one is
2,
even 2. And the next one starting from 3. I need a thing to point with. Not sure what I mean. Starting from odd 3,
6, 9, 12, 15.
we've got the
3s.
The threes. You see now, if your chart is totally neat, you'll see these very easily. Jane, you've done a really neat chart. Can you
Oh,
see?
except when I filled in tonight now, I've made scribbles.
Oh, you mustn't make scribbles. Jacqueline. Jacqueline's is neat too. Oh, beautiful.
This was only one for a bit of tipping, so I had to make it beautiful.
That is very beautiful. Can you see them there? Ones.
Just don't make a mistake.
No mistake. Right? Do we all understand? Oh, look at yours. Oh, can I hold that up?
Yeah.
Look at the, I call these the rays. Can you see that?
Yeah.
These are the rays. Look at that.
Oh, yeah.
Can you see the rays?
Oh, wow.
Wow.
Oh, wow. Well, when I discovered this, I was tremendously excited because, yes, you do.
Oh, yes, it is.
Rain
Okay,
and
yeah,
feet.
yeah.
It might go more acutely that goes out.
Mine's not 100% neat, which really inhibits seeing the patterning. All right, I want you to look at your ray and your horizontal, and I want you to tell me where the number in the ray meets the number in the horizontal. So if you're on the 3 ray, where does it intersect with the 3 in the horizontal?
I don't understand what you're
Okay. Too much jargon.
Vertical.
Yeah.
The 3 ray is along here, isn't it? Right? And the 3 in the horizontal is this one.
Oh, the 9.
And it intersects at
The 9.
the 9. And the 2 ray and the 2 horizontal
At the 4.
at the 4. I was on a chair all morning. Yeah. And the 4 ray and the 4 horizontal at the 4 ray, you have to be precise. 4 ray and the 4 horizontal So the 4, what's the next 4? 4, 8,
Oh,
right? And the 4 horizontal, where do they intersect?
16.
16.
that's
The
weird.
4 ray and the 4, this one, and the 5 ray and the 5 horizontal, and the 25, and the 6 ray and the 6 horizontal, can anybody see it clearly in theirs? The 6 ray, no, don't worry.
Sorry, when you say the single word.
The 6 ray, so we go from 6,
6 ray.
36.
it's hard to see, where is it?
36.
36, is it this one?
Yeah.
And the 7 ray and the 7 horizontal is here. Now, what do these numbers represent? What do these numbers represent?
Multiplied by themselves.
Perfect. What do you call those numbers, Brian?
Don't know.
What do you call a number squared? They're at the square of the number. Isn't that exciting?
So that's like, it's a bit like a X and Y chart.
Well,
It's different, but
It's
It's the basics.
whatever you see in it.
That's so
Mm.
cool.
It's so cool. So that's what square numbers are. A number multiplied by itself. So 2 times 2 is 2, you never knew that. 2 squared. 3 times 3 is 3,
3 times
3 squared.
3. Squared.
Do you know how to write it? 2 times 2 is 2 squared. The little 2 up the top means times itself. 3 times 3
That's 9.
is 3 squared, which is 9. So what's 4 squared, Grant?
4 squared would be 16.
4 squared is 4 times 4, which is 16. And 5 squared,
25.
and 6 squared,
36.
beautiful. Look at Grant.
We've got big white circles around.
But you're seeing a pattern there.
Yeah.
Isn't that lovely? I thought that was so exciting when I discovered it. I thought that was very exciting.
How long did it take you to develop this?
How did this come about? I was in class 5 and I was writing numbers. The children were calling the numbers and I was writing them along. I don't know what I was doing, maybe the 2s and then the 3s, or I don't know how far I'd got. And somebody yelled out, Vera, I can see a pattern. And I said, what's the pattern? And the children actually developed it. You know, I can see a pattern, I can see a pattern. So as soon as somebody sees a pattern, that's it for me. So that night, I spent all night, you know, with cardboards and drawing this chart. And I think it was 4 in the morning when I finished this chart from what I'd started in that was class 5, that was Celia's class 5. But they started to see pattern. I must have been very neat on the board in those days because they saw a lot of patterns, and of course I hadn't got all this far, but then I developed this and the children really loved it. And whatever the children really loved, then that became Pebble Maths, because if the children love it, then it makes sense to the children, which is what we want. So now we are able to change our multiples. If we want to do 4 8s, we can change it to 8 4s, we can change it to 16 2s, we can, if we've got 7 3s, 7 6s, we can make it 14 3s. That doesn't help us. 7 6s, it's easier to do the 6s than the 3s, I find, doing the 5s and the 1. Anyway, whatever floats your boat, whatever makes you happy with playing with your multiples and seeing what you're happy with. I mean, I love this for 6 times. I love this way of doing 6 times. That's just so lovely. So if I had 6 times 14, I can do that easily enough. That's 84. So 3 times 14, I could halve 6 times.
42.
Exactly. So I could work backwards instead of going to the smaller number and doubling. I find the 6 lots is easier than the 3 lots. So I could do 6 lots and halve it. So if I wanted to do 3 times 27, for example, I could do 6 lots, easy peasy, and then halve it. So what's easy for me mightn't be easy for you, what's easy for you might be difficult for me. And that's the way with the children. Some like to do this one this way and do that one that way, or whatever. And we want to encourage them to explore so that they've got a multitude of ways of looking at add, subtract, multiply and divide. Any questions on this so far? All clear? Okay, I'm now going to talk about lowest common denominator. So, don't look at me like that. All right, now, back to our fractions. Is somebody passing out? No. So, when we talked about thirds, for example, everybody relate to this? 1 part out of 3, 1 part out of 3. Stop me if you don't understand, please.
Yep.
Everybody's got that, don't they?
Yeah.
But now, if I want to add a third and a half, I want to add a third and a half. I can't. Why can't I? I can add a third and a third. Remember how we added a third and a third? What would that be?
2 thirds.
2 thirds. But I can't add a third and a half, can I?
No,
Why?
it's not. They don't match.
They don't match. So the right word for that is they have a different denominator. They have a different number on the bottom. The circles are cut into different size pieces. Yes? That's called a denominator. Right? So what I'm going to do now, I'm going to, instead of looking at this third and a half and wondering how on earth I can add them together, I'm going to get my pizza wheel and I'm going to start cutting some more. I've cut them into how many?
6.
I've cut them into 6 pieces each, haven't I? So now, what would I call this piece?
1/6.
How many?
1. Oh, sorry, 2/6.
2/6. I would call that 2/6. And what would I call my half now?
3/6.
3/6. So now I can add them and I'll get 5/6. Does everybody see that?
Yeah.
Now, how did I know to use 6? How did I know that I could cut them both into 6 so that would work out? Any ideas? Look at your 2s and look at your 3s. What's the first number they share that they have in common?
6.
6. Oh, here I go.
Well done.
Can you see that? And that's called the lowest common denominator of 2 and 3. Now I'm sure these terms are familiar, aren't they, even if you never understood them at school. But they'll ring a bell.
That makes sense.
It makes sense now? 6, I call it the first number they share. So I can cut both pieces up into 6. Now I can also tell from there that I've got, in the thirds, I will have 2 pieces, and in the half I will have 3 pieces. Can you see that?
3's into 6, 2's into 6.
Yeah. Well done, Grant. Is it making sense now? So now we can use this chart for our fractions to find our lowest common denominator. Later on we will find much easier ways of working with our fractions, Vedic techniques, but I want you to understand lowest common denominator before I move you on to much more clever shortcut ways of doing things, which I could teach you, but I want you to understand it solidly before we get too clever. So now if I was going to add a third and a quarter, a third and a quarter, how many pieces have I got to cut both pizzas into? 12. You found it from the chart. 3 and 4, you run your fingers along, and the first number they have in common is the 12. So we have to cut both pizzas into 12. How many pieces does my third get cut into?
4.
4. How many pieces does my quarter get cut into?
2.
12.
3.
Oh, 3's.
You follow that, Grant?
Yeah,
Yes. So now you can tell me a third and a quarter will be how many twelfths? One will be cut into 3, one will be cut into 4. 7 twelfths. A third and a quarter is 7 twelfths. Do you see that, Grant, or should I draw it?
We'll take that one. Yeah.
Okay. The thirds, to cut a pizza cut into thirds, to cut it into 12, each third has to go, I have to have 4 pieces in each third, right? See how that's going to create 12? 3 4s.
Yep.
So that'd be 4 twelfths. And the quarters, the 4 to make 12, there'll be how many in each
3.
quarter? 3. Well done. 3, 6, 9, 12. So this will be 3 twelfths, 4 twelfths and 3 twelfths is 7 twelfths. So you can see you can shortcut it by looking here where you don't even have to draw or cut the pizza up. With the children I like them to do that until they work out for themselves that there's a shortcut. I don't teach them the shortcuts, I want them to go, here I can see a shortcut. Or I see a pattern, I see a pattern. That's the magic mantra. So we can see a third and a quarter will be 4 twelfths and 3 twelfths is 7 twelfths. What about 2 thirds and a quarter? 2 thirds and a quarter.
10 twelfths.
8 twelfths and, okay, not seeing it? 2, yes, good Jacqueline. 2 thirds, if 1 third is 4 twelfths, 2 thirds is how many twelfths? 8 twelfths. Can you see that? If 1 third is 4 twelfths, 2 thirds, 8 twelfths. 8 and 3, even 8 plus odd 3, 11 twelfths. So 2 thirds and a quarter is 11 twelfths. So you can see that like that now, compared to how hard were fractions when you were at school.
Never did.
You never did.
I think I'd be about the same.
Does that make sense now?
Kind of, I'm getting it. I'd have to do it.
Okay. Okay, do you want to do a few?
I don't mind. If you need to move on, that's fine. I'll practice.
All right, let's do let's do 2/5 plus a quarter. 2/5. 2/5 plus a quarter. Now, do it any way you like. You can draw the pizzas and cut them up, or you can see it from there, whichever you like.
Can't that way?
Pardon?
Just multiply it by the numbers and you get your answer.
You do there, yes.
Does that work in everyone?
Sometimes there's a lower common denominator than that. If I said 3/8 plus a quarter, what would be the first number they share? 3/8 plus a quarter.
4.
3/8.
Eight.
It would be 8. 8 would be the lowest common denominator. So you wouldn't have to go to that, yeah? That'll always give you a common denominator, but not always the lowest one. 2/5 and a quarter. Anybody stuck? So, what are the denominators?
5 and 4.
5 and 4. So let's go along. What's the first number they share?
20.
Well,
Hmm?
20.
Isn't it 12?
it's 12.
Is 5 in the 12? I mean, is 12 in the 5?
Oh, I see, so, okay.
It's just not quite.
Oh,
No, it's just not like that.
5 and 4. You see why you need to be neat?
Yeah.
20. 20.
Is it these two?
Yeah.
That's the first number they share.
Okay, that's fine.
So in my 1/5 would be how many parts out of 20?
4.
4. So in my 2/5,
8.
8 parts out of 20. And in my quarter would be how many parts out of 20? 5. Altogether,
13.
13 out of 20. But I like the children to draw the pizzas and then cut them up.
I think
Otherwise
that's
it's a
good.
bit too theoretical. Yes, but some of the people are already able to do it without drawing them, which is the next step. But I like everybody to draw them until you've convinced yourself that there's 4 5s in the 20 and 5 4s in the 20. You know, so that you feel solid with that before you move on to doing it without the pizza. I'm not going to do take away fractions or multiply and divide fractions right now. I want you to be really solid with the chart, with multiplying and dividing from the chart, with multiplying and dividing using the number wheels so you know your remainders, so you're aware of your remainders, right? So if I say to you 43 divided by 8, is it going to be an even number of 8s? How do I know it's not going to be an even number of 8s? Because 43 is an odd number, so that's not going to show itself here. It's going to show itself more nicely on the number wheel, because it's going to show the remainders. Or we can do 4 10s and a 3, 1 10, 2 10s, 3 10s, 4 10s and a 3 divided by 8. You can do it this way. Got the answer?
5 remainder 3.
5 remainder 3. So then you can do it this way, you can go to your wheel, right? But you knew this might be the best place to go because it's not an even number of 8s. Or we could go to 43 in the 8s. Here's the 8s, correct me if I go wrong. Right, I go here, I can see 1, 2, 3, 4, 5, remainder 3. I can do that. So we've got 3 ways now, 3 mediums. Our pebbles, our trusty pebbles, our number wheels, which I think are a lot of fun. They really show the remainders nicely and solidly. And our multiply chart, which is showing us a lot of things. It's showing us our factors, our primes, our squares, and our lowest common denominators. So we've learned a lot about multiply and divide with these 3. So how do you feel now, folks, about multiply and divide compared to, say, before we started our class? I don't mean today, I mean our course.
All that stuff, no, it's never like
Does it make more sense?
Yes, but practice, and it's doing your wheels and your charts as well.
Yes,
Yeah.
but is it becoming, falling into place?
Yes, I feel more confident that with practice it will become easier.
Yeah, but is it, I suppose what I'm after is, does it make sense? Does it make sense? And
Yeah, but it's just different.
it's very different from the way you go
Mm.
to school.
it's still I'm learning.
Mm.
Yeah. But is this more harmonious with your thought patterning, or
It's getting there. I think I'm just a little bit overwhelmed with the fraction part at the end of all that. Like I was doing all, everything else was coming clear, and then you hit that, and I just sort of.
I went a bit too quickly?
I think you were the same too, weren't you? We just sort of went.
That could be old memory, old trauma of fractions.
It could be.
Oh,
But the,
completely.
You blanked?
Mm.
As soon as I mentioned fractions, you...
Yeah.
Well, it didn't even register as something I remember. I know the word, but I have no idea what they taught it to me at school.
Yes, yeah, okay. But you understand a fraction is a part of the whole,
Yeah.
yes? We all understand that? Yeah?
I find this fabulous because I could not understand fractions at all. I mean, I couldn't work out any of it, and then just look at that and go, wow. If somebody had showed me that, I would have been so smart. I would have slept through the exams.
You were smart. Understanding something doesn't make you
I
smart.
never understood where the lowest common denominators come from, but this makes it really clear, so it's very simple to see.
So it's illuminating
Mm.
things that before were in the dark. That's what I'm after, whether this is really helping you to see
Yeah.
where it all
absolutely.
springs from.
Yeah.
I'm not expecting you all to be mathematicians because you haven't had the time to practice.
Well, the nice thing is it's actually all on one chart.
It is all on one chart. There's a lot on that, isn't it? It's just a whole bunch of numbers and it shows us everything.
you'll see this down the street.
You've got your squares, you've got your
Squares, and we can
multiply,
talk about
divide, your
square.
fractions,
Your primes.
your
I'll just
fractions.
mention one last thing, which is square root, which you may or may not have heard of.
I've definitely heard of that.
So if I say the square root of 9, I'm asking what number multiplies by itself to make 9. So the square root of 9 is 3. And how we write that? The square root of 9 equals 3. From your chart, what's the square root of 16?
8. Oh.
The 16 with the circle around it
Yeah.
is on which?
Is-
4.
It's the 4 times the 4, right? So the square root of 16 is 4. What number multiplies by itself to make 16? 4. 4 lots of 4 is 16. Does that make sense? So if I say the square root of 25, because I've got circles around lowest common denominators. I'm really making this hard for you.
5.
5. 5 times 5 makes 25. The square root of 25 is 5.
So the square root of 49 then would be 7.
Perfect. Well done, Jane.
I'm going to remember 49 forever because it just doesn't fit anywhere.
That's it. It's a bit of a misfit, isn't it? But it's a glorious number. I mean, they're all glorious in their own unique way. Wax lyrical. So I think that'll do us for tonight. And have fun with your homework and doing your charts and practice. And we'll gather in